Hello, my name is Ritisha and welcome to our channel Coding with JS. We will understand dynamic typing and how a variable's type can change at runtime.
JavaScript is what we call a dynamically typed language. That phrase gets used constantly and explained almost never. So in this video, we are going to make it concrete. We will watch a single variable change type 4 times. Then we will look at what that costs you and what it buys you. And we will connect it back to the engine from video 2. Here is a variable holding a perfectly ordinary number. At this exact moment, its type is number, nothing else. Let us look at what memory holds right now. One labeled box called thing holding the number 42. Now watch what happens when we put a string into it. We assign a piece of text to that very same name. In many other languages, this line would refuse to compile. The variable was declared holding a number after all. But JavaScript accepts it without any complaint whatsoever. The box now holds a string and its type changed with it. And we can keep going as many times as we like. Now the very same name holds a boolean value instead. The type changed again and again, nothing objected. One more time, this time with something more complex. Now it holds an array, which is an object underneath. 4 assignments, 4 completely different types, one single name. So what is actually going on underneath all of that? Here is the single most important idea in this whole video. The type does not belong to the variable at all. It belongs to the value that the variable currently holds. The variable is just a label pointing at something. Labels do not have types, the things they point at do. Once that clicks, dynamic typing stops feeling mysterious. Contrast that with how a statically typed language works. In Java or C, the variable itself carries a declared type. You state that type when you create the variable. And the compiler checks every assignment against it. Assigning a string to a number variable fails immediately. It fails before your program is ever allowed to run. That is genuinely valuable because the mistake never reaches a user. You find out in your editor seconds after writing it. JavaScript gives you the opposite trade completely. Nothing is checked until that exact line actually executes. So a type mistake can sit in your code for months. It only appears when a user takes some unusual path. That is the real cost of dynamic typing, stated plainly. The error is not prevented, it is merely postponed. And it is postponed until the worst possible moment. So what do you actually get in return for that? The first benefit is simply writing much less code. There are no type declarations cluttering your variables. For a small script, that is a real and immediate saving. The second benefit is considerably more interesting though. Here is a function that accepts absolutely any value. It reports the type and the value together as text. Notice there is no type written anywhere in the signature. We never told JavaScript what kind of thing X would be. So this one function handles every type we can pass it. Let us call it with a number and then with a string. The same function body handles both without any changes. And the output confirms it worked for both of them. In a statically typed language, this needs generics or overloads. Those are powerful features, but they take real effort to write. Here you simply get the behavior for free by default. That flexibility is genuinely why JavaScript spread so quickly. There is a performance angle worth understanding as well. Remember the just-in-time compiler from the engine video. It watches which functions run often and compiles those. To compile well, it assumes the types stay consistent. If a function always receives numbers, it compiles for numbers. That specialized version is dramatically faster than a general one. But dynamic typing means you can break that assumption. Pass a string to that number function just once. The compiled version becomes invalid and is thrown away. the engine falls back to the slow interpreted version again. That is called deoptimization, and it is genuinely expensive. So dynamic typing gives you flexibility with a hidden performance cost. Which leads to one very practical piece of advice. Just because you can change types does not mean you should. Keep a variable holding one kind of thing throughout its life. Keep a function accepting one shape of argument consistently. Your code becomes easier to read for other humans. And the engine rewards you with its fast compiled path. Both benefits for a habit that costs you nothing at all. There is one more part of this story worth mentioning. A lot of teams want dynamic flexibility and static safety. TypeScript exists to give you exactly that combination. You add type annotations, and a checker verifies them before running. Then all the types are stripped out completely. What actually runs is ordinary dynamically typed JavaScript. So TypeScript is a checking layer, not a different runtime. The engine never sees a single one of your annotations. Which is why learning JavaScript properly comes first. TypeScript makes far more sense once this model is clear. So let us bring the whole picture together now. Types in JavaScript belong to values, never to variables. A single name can hold 4 different types in 4 lines. Nothing is checked until the moment a line actually runs. That costs you early error detection, which is a real loss. It buys you flexibility and considerably less code to write. Stay consistent anyway for your readers and for the engine.